Moving on to classroom example 5, we want to solve and graph 3 times x plus 5 in parens minus 1 is greater than or equal to 5 times x minus 1 plus 7. All right, so let's use the distributive property first to get rid of the parens. Distribute the 3. 3x plus 15 minus 1 is less than or equal. Now I'm going to distribute the 5. 5x minus 5 plus 7. And we'll combine like terms here. This side is going to become 3x plus 14, because 15 minus 1 is 14. And this side is going to become 5x plus 2, because negative 5 plus 7 is 2. All right, so I can either subtract 3x from both sides or subtract 5x from both sides. Doesn't matter. I'm going to subtract 3x from both sides, and I'm left with 14 is greater than or equal to 2x plus 2. All right, since I want to get the x by itself, I'd better move that 2 over. So I'm going to subtract 2 from both sides. So I get 12 is greater than or equal to 2x. And now I want to get the x by itself, so I'm going to divide by 2. But since this is a positive number, I do not swap the sign. I get 6 is greater than or equal to x. So x has to be less than or equal to 6. Let's pay attention as we draw the number line. If this is 0, 1, 2, 3, 4, 5, I'm going to put 6 on my number line. X has got to be less than. Notice the arrow always points to the smaller number. So we're going to go this way on the number line. Can x equal 6? Yes, it can. So we're going to have a square bracket. But x is going in that direction, the negative direction. So what are my valid values for x? It can be all these negative numbers. In fact, it can go all the way down to negative infinity. And since you never touch infinity, you're going to have a paren. But the biggest possible number is 6. And because of that little equal sign, it can equal 6. So this is interval notation for less than or equal to positive 6. And again, you're going to want to check your number, check your answer. Like I think if I have solved this correctly, 0 should solve my original inequality. 3 times 0 plus 5 minus 1 should be greater than or equal to 5 times 0 minus 1 plus 7. 0 plus 5 is 5. Minus 1, that should be greater than or equal to 0 minus 1 is negative 1 plus 7. 15 minus 1, is that greater than or equal to negative 5 plus 7? Is 14 greater than or equal to 2? Yes, it is. So I have selected the correct solution region. All right, so you're going to go ahead and try practice 8 now on your own. In classroom example 6, we have a compound inequality. So up until now, whatever we've done to the left-hand side of the inequality, we have to do to the right-hand side, or they're not equal anymore. Now we see that x is greater than a certain value and at the same time less than a certain value. So we want to get x by itself in the middle of this compound inequality. But whatever we do to the middle, we have to do to both the left and the right. So I have negative 24 is less than 5x plus 1, which at the same time is less than or equal to 6. And we want to get x by itself. So the first thing I'm going to do is subtract 1 from the middle, which means I need to subtract 1 from the left and the right also. Negative 24 minus 1 is negative 25. Bring down your less than sign. I've got 5x. Bring down your less than or equal to sign, and 6 minus 1 is 5. All right, and now since I want x by itself in the middle, right now it's being multiplied by 5. To undo that, I'm going to divide by 5. But whatever I do to the middle, I have to do to the left and right. This is going to be negative 5 less than x less than or equal to 1. I'm not swapping the signs because I divided by a positive number. So x has to be greater than negative 5, can't equal negative 5, greater than negative 5, and at the same time less than or equal to 1. So let's go ahead and put this on our number line. Here's our 0, 1, 2, 3, 4. Here's my negative 5, and here's my positive 1. X has to be greater than but cannot equal negative 5, all these, but at the same time, x has to be less than or equal to 1. So now this is my interval. They're not going off into infinity. X has to be greater than negative 5, less than or equal to 1. And in interval notation, we go right from our graph. Cannot equal but greater than negative 5, can equal less than 1. And so that's my interval notation.